All right, look what I have today. It's another Denon. This one is the AVR-S930H. Haven't even powered this thing up yet. Thought I'd just show you a quick look around on this unit. Definitely got a bunch of AV inputs and outputs back here on the back of the unit. All right, here we go. AC power on. Get a green blinking light. And then immediately I get the red blinking light of death. So let's go ahead and first thing, we'll connect to these bias test points, these plugs that you see down here. We'll measure the bias voltage and we can actually check DC offset on each channel by looking at these plugs down here. So let's go ahead and do that real quick. I'll get the overhead camera fired up and we'll see what happens. Okay, so I have my special Denon bias adjusting test jig connected right here. And I only have one lead going into it, and the other lead's just kind of hanging loose right here. And I'm just going to check for DC offset. So as you can see, I have a test lead connected right here to chassis ground. We'll fire this thing up once again. And that channel looks good with virtually no bias offset. We'll go to the next channel now. Here we go, second channel. And I've got 14, 30, 40, 50 volts. That's not good. Let's go ahead and put this thing in the 60 volt range. And we'll put it on min-max. Power this thing up one more time and we'll see what the maximum voltage is that it produces. So I see a max voltage of 20.25 in the positive direction and negative 51.68 volts in the negative direction. That is going to be a problem. Let's go ahead and just test every other channel just to make sure there's not a problem with another channel. So I'm going to set my meter to min-max so I can capture the minimum and the maximum, but it's on actual volts right now. So on this one, I saw a max of 1.55 and a minimum of minus 438. But I didn't really see any issues with that channel. That's normal bias offsets as it's powering up. Next channel, power on. That channel looks perfectly fine. 7.55 and minus 2.43. I'm perfectly happy with that. Let's reset min-max, switch to the next channel. Here we go, power on. Perfectly happy with that channel. Basically 0 volts. We can look at the min-max 1.61 and minus 1.96. No problems there whatsoever. Let's switch to the next channel. All right, here we go, power on. That channel seems to be perfectly fine as well. And finally, the last channel, min-max is reset. Here we go, power on. And I'm perfectly fine with that channel as well. So it looks like it's just the second channel that's having this problem. So we'll go back to it real quick and do one more test. All right, min-max is reset once again. Let's go ahead and power this unit on one final time. And yeah, I'm seeing, wow, it's all over the place. I can't believe it, how it goes positive and negative simultaneously. So I'm seeing positive 19.56 volts that time and a negative 47.71 volts. Well, at a minimum, I've got to pull this whole thing apart and get the amplifier board out of this unit and do some tests on some transistors, capacitors, and whatnot, and see if I see anything out of the ordinary. Okay, so this one's going to be kind of hard to film, but if I look down here, so let's go ahead and start way over here. So this transistor, the bias tracking transistor, and the other output transistor are part of the good channel. Now this is the bad channel, and it's really hard to see, but I swear I see a crack in the solder connections on both of these transistors, and that is the channel in question. Going over here, everything looks pretty good, and the rest of these channels all look about the same. Once again, getting back over to here to the bad channel, and I swear I see cracks where they soldered to the board. Isn't that something? Well, let's pull this thing down to kit form and we'll see if we actually see anything. Okay, I'm thinking this one's not going to be that bad to get apart. So I've got a bunch of the cables already disconnected. As you can see right here, these are all disconnected. And those connect from the main board to the front board. This is from the power transformer to the front panel display, plugs in right there. Got this ribbon cable ready to fold back right here. This cable ready to fold back. Let's go ahead and try to tie it out of the way so it doesn't flip back. And so I've got the screws out underneath the unit. And so I'm thinking I can just lift the whole amplifier assembly, if I can get the chassis to open wide enough. I can just take the whole amplifier out of the unit without having to strip everything else. Okay, let's get that part off the bench and we'll look at the amplifier next. Okay, so I've got the amplifier out, it's up on the bench, and I've highlighted the defective channel in red right here. So it's these two output transistors, this bias tracking transistor. So let's just go ahead and do some ohm meter measurements on the output transistors and see what they test like in circuit. So first we'll go ahead and check from base to collector. I see 0.606 volts, perfectly fine. Base to emitter, 0.660 volts, and collector emitter, and I see open. Next we'll check base to collector on the other transistor, 0.629, 0.630, perfectly happy with that. Base to emitter, 0.698, 0.7. That seems to be okay. And then collector emitter. And I do see a weird junction, 0.837. And if I reverse the leads, I see 0.5. Well, the nice thing about this is I've got another channel to compare it to. I see the same thing, 0.5. And about the same, perfectly fine. So bias tracking transistor, let's see. 560, 559, collector emitter, 1.3, and 641. Check this one over here. 561, 561, 1.3, and 648. So as far as I can tell, the outputs and the bias tracking transistor are perfectly fine. So I think I'm going to have to pull a schematic and see how the audio is coupled, because if it's directly coupled, we could have a driver issue causing a DC offset, because it went positive for a few seconds and then it went severely negative, which is very odd. So I'll grab a schematic and we'll take a look at it. Alright, so I'm going to hook my homemade power supply up to this unit and supply plus high B, which is the high B plus, minus high B, which is the minus B, and high ground and pre-ground to this unit. And I'm just going to simply short pre-ground to high ground, because as we found out in the last video, that actually controls the differential amplifier ground. So that needs to be attached together right here. Otherwise, we don't have a good differential amplifier reference. And so here is the schematic for the power amplifier for the surround back left, which is the channel that's having the issue. So I've got the two output transistors. They are Darlington outputs. I've got the 4.47 ohm, I think they're 1 or 2 watt emitter resistors, although I think they're very underrated. This is the pre-ground right here, so it needs to be attached to the main ground. So the high B plus goes to the collector of this transistor. The high B minus goes to the collector of this transistor. And the ground is actually going to go to the cathode of this diode, because that's the only applicable place I can find to attach it to without removing the complete board. And I've shorted the differential amplifier ground, which is this green right here, to this green right here. So we're going to go ahead and fire this thing up and see what happens. Okay, so here's what I've got going on. I've got B plus going to the collector of this one transistor. I've got B minus going to the collector of this transistor. And I've got my ground going to this diode and then over to here for the differential amplifier ground. I've got my voltmeter in the 600 volt range. And I am monitoring the test point of the emitter resistors right here. So I'm going to go ahead and fire this thing up and bring it up slowly while watching the current mainly. I don't want to self-destruct this thing as I bring the voltage up. So let's go ahead and bring this up and see if we get a DC offset. So I have 16, now I have minus 20. And now it's regulating at 0 volts DC offset. What is going on with this thing? It's perfectly fine. Let's go to the millivolt range. So I actually only have 3 to 4 millivolts, and I'm up to the full 125 volts AC input right now. And it's doing exactly what it should be doing. It's kind of hunting back and forth. The amplifier is working perfectly out of the unit. Is this going to be another issue of a bad connection? A pin fitment issue? I just don't get it. So the total AC draw at 120 volts AC input is about 65 watts right now, and most of that is going to be the power transformer right here. So let's go ahead and actually measure the DC bias and see what it has to say. Okay, so I have both probes into the millivolt DC input now, and it's regulating at perfectly 10.4, 10.5 millivolts DC bias. That is absolutely perfect. What is going on with this thing? Are these having nothing but pin fitment issues on these amplifiers? Is that what's killing these things? So next I'm going to connect a speaker to it. I'll feed an audio input to it and see if we get sound out of it. Okay, well, there is certainly something going on with this channel because listen to this. So that's the speaker connected to that one channel. Nothing on this one. Nothing. 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 And nothing. But if I connect it back to this one channel, the surround back left, that is an issue. So I've got to figure out what is causing this issue. Definitely pulling a lot of current. I mean, I only have a couple hundred microfarads of filtering. But yeah, it's definitely something going on with this one channel. Well, after some extensive troubleshooting, I believe I have come to a logical conclusion. I believe this transistor right here, Q461, which is a KTA1024Y, is defective. So let's go ahead and test that transistor, and I pulled one out of another channel and we'll test it and do a comparison. So this is the suspected bad transistor. And I see a PNP with a beta gain of only 15. That seems very low to me. So let's test one that I pulled out of another channel and see what the gain is. If it's 15, then I'm screwed. So here's one that I pulled out of a different channel. Look at that. Almost 10 times the beta gain, 147. And a forward voltage of only 0.645 volts. The other one had almost 0.7 volts. So I need to see if I can find a replacement transistor for this. So it is a KTA 1024, probably the same as a 2SA 1024. Let me see if I have any of these things laying around and we'll put it in here and see what happens. And just because I saw cracks in the solder connections when I looked at this thing with the cell phone, I'm going to go ahead and reflow every transistor on this unit. I just want this thing to be extra, extra solid. Okay, all the connections have been reflowed. Time to put this thing back together and give it, hopefully, a final test. All right, new heatsink compound has been added to the heatsink and the insulators. They're all intact, as well as all of the output transistors and the bias regulating transistors. So I'm going to go ahead and put these two halves back together, mate them together, and we'll fire this thing up once again and hopefully better results. All right, I have the amplifier reattached to the heatsink at this point. Let's go ahead and power this up, and I'm going to bring the voltage up slowly. Last time, remember, we got a terrible hum. Just get the slightest little hum, then it goes away once that Zener diode takes over. And so there we are at 120 volts AC input. Let's put some audio into it now. So far working absolutely perfectly. I'm going to take it back down to 0 volts. Go ahead and attach a voltmeter and I'll measure the DC offset as the unit comes up to power. Okay, so I do have my millivolt meter connected to the bias test point. So I'm going to bring this up slowly and we'll see what we get. Audio is still playing. And that's at a full 125 volts AC input. And I've got about 20 millivolts offset. I'm certainly very happy with that. So next, I'm going to go ahead and disconnect my test leads, put this thing back together, and hopefully we have successful power up. All right, here we go. First power up after reassembly. Power on. And I get a speaker relay click. Awesome. Let's put some audio into it now, make sure it works. Okay, I've got the unit up and running. It's powered up, and I have my MP3 player connected to the input, and I have only the surround back left channel selected at this point. So let's hit play. And it certainly sounds good. No issues with that whatsoever. That was the channel that was giving us problems, that was shutting this unit down. Anyhow, up and running once again, the Denon Integrated Network AV Receiver AVR-S930H up and running once again. All because of a single bad transistor. There it is right there. Just one freaking bad transistor. That was it. Anyhow, I certainly hope you enjoyed this video on the repair on the Denon receiver. Go ahead and leave me a question, a comment, a concern down below, good or bad. I do try to respond to the comments when I have time. While you're down there, hit that subscribe button and like this video. It really does help my channel grow. You can follow me on social media, Facebook, Instagram, Twitter at Norcal715. You can email me, norcal715videos@gmail.com. That is the best way to contact me. Please be patient. I have a full-time job and I do this in my spare time. If you do send me a message on Facebook, Instagram, or Twitter, please be aware, I actually don't check those things very often. It might be weeks or even months before I respond to that. So please, if you want to contact me, use the Gmail address only. Remember, with your help, we can try to keep these things out of the landfill, out of the recycle bin, and out of the e-waste facility. Everyone, thank you for making it to the end of this video. I really do appreciate it. Everyone have a great day. Thanks so much for watching. Bye-bye.